Hello, I'm Meet, and today we are solving Advent of Code Day 3. So, in this day, we have given a single string which has some weird characters, and specifically, there are a specific instruction called MUL, and the so we have two parameters inside of that, that is the number x and number y, and this number can be between 1 and 3 digit. And what we need to do is we need to find such expressions inside of that string and multiply those the expressions and add them up to get the final instruction, final answer for that scope. So let me explain it more clearly. So here we have the single string that we have been given, and we need to find MUL comma bracket and the other two digits. This could be between 1 and 3 digits. So 2 could be 1 to 3, or in other words, so 2 could be 1, 2, 3, 4, 5, 6. It could be a 3 digit number, and 4 as well could be a 3 digit number. So we need to multiply these together and add these for all the multiple expressions that are there. So in this case, there are 1, 2, 3, 4 expressions, and we need to multiply the digits inside of that and add them up. So how do we approach is basically we can find them. This is pretty straightforward. The part one, which is to get a regular expression, which will be defining this multiple MUL character and followed by opening bracket, and then we have a digit. It will be spanning from 1 to 3 digits followed by a comma, and then again a 3 digit characters, and then followed by a single closing bracket. So once we find all of these, we can get the matched expressions, and with using match groups, we can get these expressions, that is 2 and 4, that the digits inside the multiple regex. So we can get 2 and 4 individually and multiply them after converting them into integers. Once we have that, we add these together and get the final score. So that is part one. Let me show you how we can implement this part one in Golang. So for part one, what we need to do is simple. We first use we first get the input lines, which will be simple line by line instructions, and the sample instruction just has one line. But if you get your input, that will be 6 lines. So we need to combine those together. So we'll create a score one, and for each lines we need to iterate over all the lines and multiply the score, or add the score after multiplying every expression in that line. So we need to write the multiply function first, and at the end we print out the score. So what we can do is we need to write the function multiply, and for that we use regexp and strconv, which will be used for string to integer and conversion, and regular expression, that is the package standard library that we'll be using for this implementation. So we'll take in multiply function will take in a line which is a string, and it will return an integer which is a score, which will be the addition of all the multiply expressions in that string. So first we'll define the regular expression. This will call it multiple regex, mull regex, and we will define it using the gxp dot must compile, and this must compile takes in one string which will be the actual regular expression, and it will return a regular expression object. So we define the regular expression as MUL. So this will be just a character sequence of characters MUL one after the other, and then followed by opening bracket, that is the actual bracket, and we need to escape it because it's a regular expression. And then we need a match group that will be used to extract out the specific parts of that regular expression. So for the first match will be the entire regular expression, and the subsequent uh, matches will be the match groups that we will be defining here. So this bracket defines a match group, and inside of that we will be defining digits. So i- we need a digit here, and we need 1 to 3 digits of this. So what this match group is defining is that any characters of a digit which are of length 1 or 3. So it could be 1, it could be 1 2, it could be 1 2 3. If you're not getting it, so it could be 9, it could be 99, it could be 999. So it could be 999, and then followed by a comma. And then similarly, we will have one more match group that will be defining the second number, which is y. So the first one was x, then will be y. So we do the similar thing, that is to get the digits between the length 1 and 3. And then we need to escape this closing bracket for that multiply expression, and that defines the multiple regular expression for this string. And then using multiple regex as a regular expression, we'll call the function find all string submatch. So what this function returns is takes in the strings, and we want how many instances of that uh, matching we want, and it returns a list of strings. So within a string, within a match, we can have multiple match groups, or so we can index it using accordingly. So once that is done, we pass in the line, and we use it -1 because we want all the matches, and we define the score. Then for each match, then for each of the matches, we iterate over them, and we need to convert that match. So first, we will be getting the first match, that is uh, the first match is this, because the zeroth match will be the entire string, that is Mull bracket the x and y closing bracket. So we need to get the 1 and 2 second index as the x and y numbers. Once we have that, we'll just log it out. This is not needed, but I'll keep it short. So we get x, and now we need y, so that will be the index 2. So that is that, and the similar things. Then we multiply x and y together and add it to the score, and this will return the score for that particular line. So these are all the expressions that we have found in that line, and that defines part 1. So if we run this, you can see that this gives a total of 161, which is the expected output for the sample. For the part 2, it becomes a little complicated, that we have something called do and don't instructions. So what do and don't will be doing is, if there's a do before a multiple expression, then that expression gets enabled, and if there's a don't expression, then the multiple expression is disabled. That is, we cannot consider that multiply expression. So in this example here, see, so the starting multiply doesn't matter because there's no do or don't before that, so it is enabled by default. But this expression is disabled because there's a don't string before it. And similarly, this one is also disabled because there's a don't before this expression. But this last one is enabled because there's a do string in this. So what we need to do is the same expression, is the same thing. That is, we need to grab all the multiply expressions which are enabled, and multiply the x and y numbers and add them up for this string. So that looks quite simple, but it's a little complicated because we need to sort of get where is the multiply expression disabled or enabled. So for that, what I think of is one of the approach is, we can find the indexes for do and don't, and then trim out the portion before or after do or don't, and consider those portions as processed. So let's take for example this one. Now we have so here we first check if the don't. So if we find don't, then we say that disabled enabled is false, and this expression, so everything before is considered as valid because there's no don't before this. So we take everything after this and use this as an enabled part of the string, and then we process the rest of the string, which will be everything after don't. So this will be enabled is set to false. And now once we have found that do or don't here, so here there is no don't, but we have found do here. So everything, if that was enabled was false because we found don't, so enabled becomes false. Then if we check if there was everything before do should be disabled because enabled was false initially. So now we discard this part, but we need to consider this part afterwards. So we take everything after do and process it further because so here there is no do and don't. So we have to consider this part as valid or enabled. So we combine everything before this and this part. So we get everything here and here is which is the valid string. And we do the similar thing, which is to grab or match the regex for multiply expression, and we simply add or add up the multiplied values together for that string. So one more catch over here is the input, that is it spans over 6 lines or multiple lines. For me it was 6 lines, so we need to take care of that. So let us get started with the implementation. So first I'll import strings because I will be using it, and so the flow will be the similar, but we need to take care of the strings or the lines that are in that input. So we initialize the empty string, line string, and for each of the lines in the input, we need to iterate over them and concatenate that as a single string. So we are basically taking all the input lines, there will be multiple lines, and combining them into a single line string called line str. And then we need to add up the values for multiply, which will be after we do the strip do and don't and evaluate the correct strings or enabled strings for that multiply expression. And we will pass in the line string, which will be a single string for all of the lines combined together in a single string. So this will be the output for part 2, score 2. And we need to implement strip do and don't, which will be a pre-processing kind of thing for this part 2. So we just add up with the multiply functions after we have processed all the lines. So this will take in lines, which will be a string, and we will return string because we have to pre-process these strings. So what we have to do is we first enable flag, which will be true by default, and the result will be an empty string. That will be the final result that will be returning from this function. And don't offset, I will like to create it with the length of this don't string that I will be using because I need to trim out the portions of it. And do offset will be similar for the do function that we have in the string. So we will create a for loop while we are processing the lines, and this at least we have something to process, that is the length of the line is greater than 0, so we'll process strings and trim off the portions that contain do or don't and everything after or before the do and don't strings. So we find the strings index with the do and don't strings in the line, and if we have found each of the indexes, we need to store them. So strings or index will return the first matching index with that string in the given string. So this will be the input and this will be the string that we need to find in this line or string. So we'll find do and don't in that line, and if don't index is -1, that is we have not found don't index, that is there is no don't expression in the string, and the do index is we have not found either do or don't, or we have not found both do and don't. We simply check if the enabled was true, and we append this line into it. And if that, we simply have to break out from the loop. And there's a second condition, which will be the bulk of the uh, processing, which will be the don't index is not equal to -1. That is, we have don't string in the line, and the don't index is less than do index. That is, don't index comes, don't expression comes before do, or the do index is not found. That is, we have not found do. We need to check if it was enabled, and if it was enabled, we add that portion of the string before don't index, and we set enabled as false because we have encountered don't string and do index is not found here. So we set enabled as false, and then we chunk off the line. That is, we consider everything. We remove the portion before the don't offset and add it to the don't index. So where we have found a don't index, and after the four or seven characters, that is don hyphen t square brackets. So everything before everything after that is removed, and we now need to process the remaining string. So in the second condition, that is, we have found do, and we need to process this. So if enabled was true, that is everything before this was enabled, then we need to append everything before this do index. Else we need to set enabled. So not else, but after this, what we do is if enabled was false, then we set it to true now because we have found do in this string, and we need to chunk off the string, the line as everything before do and the do index. So again, we need to remove everything before do and the offset of that. That is four characters that will have. So we have processed everything before do. There is nothing left in the line to process right now, and we return the result. So you can see here we have used strip do not in line string and then pass the expression, the result of this into multiplier, which will process the line. So this will be a single string that will be passed into multiplier, which will get us uh, all the expressions for multiplier and add up the results for this. So this will be the result. So that's it from part 2 of day 3, and we have implemented this solution in Golang. So that is it from part 2. So it is 48, and you can see that is indeed correct. So that is it from part 2, and that is wrap for day 3. Hope you like it, and I will see you in the next one. Thank you.